Hello everyone, I am Dr.M.Murugalakshmi, Associate Professor of Chemistry, the Standard Fireworks Rajaratnam College, Paviman, Sivagasi. And in this module, we are going to discuss about the types of bond cleavage, that is heterolytic and homolytic bond cleavages, and what are the types of reagents like electrophiles, nucleophiles, free radicals, and about the reaction intermediates, that is carbanions, carbocations, carbenes and nitrines. Now let us move on to the basic introduction about the organic chemistry. And what is organic chemistry? It is a branch of chemistry which involves the scientific study of organic substances which are occurring in nature, and these compounds are covalently bonded carbon atoms. And this branch of chemistry primarily deals with the structure and chemical composition of organic compounds. Not only the composition, we are going to discuss about the physical and chemical properties of organic compounds and their reactions. And we can also discuss the advancement in the fields of organic chemistry which are having numerous contributions to human society, such as synthesis of drugs, polymers and other natural products. And this also involves an important application of that is designing and construction of organic compounds for various practical purposes. And the term organic was coined because the field of organic chemistry was initially finite to compounds that were produced by the living organisms. Now we will discuss about the types of bond cleavages. What do you mean by cleavage of bonds? Actually, when you are having a compounds like AB, okay, it will be ionized as, or it will, if the bond is ruptured, means what happens here, the breaking and making of bonds occurs. The bonds may cleave in two ways. What is that? Homolytic cleavage and heterolytic cleavage. Here we will see what is homolytic cleavage first. If the covalent bond, that is the bond between A and B, okay, the two elements are A and B, they break in such a way that each of the elements gets its own electrons. So equal sharing of electrons takes place. It's called homolytic cleavage. Each element gets an electron. Homolytic cleavage results in the formation of what? Free radicals. And in the above figure, we have used an arrow. That arrow is called fish hook arrow, which signifies that there is a movement of only one electron to each atom. Next we will see what is heterolytic cleavage. If the covalent bond between the two elements, that is A and B, if it breaks heterolytically, that is unequally, it results in the formation of charged species. This type of bond breaking, where the electrons are unevenly distributed, is called heterolytic cleavage. And we can see the explanation in the figure. In the above figure, we have used arrows to signify the movement of electrons. Here a regular arrow is used. It signifies that two electrons are being moved to B, that is the element B. So you are getting the cation A plus and B minus. And next we will move on to what is reaction intermediate. We are seeing only the preliminary idea about each terms involved in organic chemistry reactions. Now we will see reaction intermediates. The intermediates can be understood as the first product of the consecutive reactions. For example, if you consider a chemical reaction like A giving B and B is converted to C, then B can be said to be here intermediate for the reaction A to C. The reactions in organic chemistry occur always via the formation of the intermediates. And some of the intermediates we will see now. First we will see what are carbenes. So carbenes, that is CH2 double dot. They are neutral species and reactive species having sextuple of electrons in their outer shell and making them to be always electron deficient. So the carbenes are the species having two odd electrons. We can classify them based on their spin states. Now we will see singlet carbene and triplet carbene. Based on their spin multiplicity, we can classify them as singlet and triplet carbene. What is singlet carbene? Here in singlet carbene, the electrons are present in different orbitals with opposite spin states. The electrons are paired in sp2 hybrid orbitals and they behave as a paired electron. So what happens to the spin multiplicity when you use this equation? Spin state is equal to 2s plus 1. Using that equation, when you substitute the spin multiplicity as 0, because all the electrons are paired in orbitals, so we can have the spin multiplicity to be 0. So 2 into 0 plus 1 is equal to 1. The next we will see triplet carbene. Here both electrons are present in different orbitals and they possess the same spin and the spin state is 2s plus 1. Here the s for the triplet carbene is 1, so the value is coming as 3, so it is called as a triplet carbene. So based on their spin multiplicity, we can classify the carbenes into two types. One is a singlet, another one is a triplet carbene. And the triplet carbene hybridization, they possess the sp hybrid orbital with a linear shape. And they have a bond angle and bond length of 180 degree and 103 picometer respectively. And they have a lower energy. As far as the energy is concerned, the triplet carbene is having lower energy and it is more stable. The next we will move on to the next intermediate, free radicals. Free radicals in organic chemistry are formed only by homolytic cleavage of the carbon bonds and the shape of the species formed is always planar. And the hybridized state is sp3 with odd electron being placed in the p orbital. And if the p orbital is relatively stable, it may possess a planar structure like this. Here the fish hook arrow is like that of the homolytic cleavage, it represents, and we will get the two free radicals after the homolytic cleavage. Next we will move on to the next intermediate, carbanions and carbocations. See, these are generally created by heterolytic cleavage of the group attached to a carbon without removing the bonded electrons. And this makes the carbon to have a pair of electrons, thereby imparting the negative charge on the carbon. So CH3 minus is isoelectronic with ammonia. You all know that, isn't it? And it is sp3 hybridized. If it is sp3 hybridized, the shape is here pyramidal, owing to the presence of a lone pair of electrons. So carbanion is having the negatively charged carbon species with the sextet of octet of electrons. And next we will see carbocations. These are they are also having sextet of electrons on the carbon containing the positive charge, and hence they are termed as cations. Okay, carbon which is possessing the positive charge, it is named as carbocation. And here also the hybridization state of the carbon is sp2 and it has one empty p orbital and the shape is planar. And this is also formed generally by the heterolytic cleavage of the carbon-carbon bonds. And another important term that you have to remember in organic reactions is transition state. Okay, up to this we have seen some of the names of some of the intermediates, and we will also discuss the another term, transition state. We saw the intermediates that could be formed in an organic reaction. Now let us have a look into the transition state. Here the difference between the intermediate and the transition state also visualized in the energy profile diagram. The intermediates in organic chemistry are formed in a multiple step reaction, and some reactions can occur in a single step without having to form an intermediate, and these reactions will occur by going through the transition state. And this can be clear by looking at the energy profile diagram for the reaction, reactant or giving product. You see the picture, it will clearly explain the energy of your reactant and the product and the energy of the transition state. It is always high and it is indicated in the figure, and that energy difference is called activation energy, each and every reactant that should attain to come into the product. The next, the transition state corresponds to the highest energy in the reaction, and in it can give either the products or in the case of a reversible reaction the reactants. Okay. So consider a reaction A giving D. Okay. We may expect the step, what are the steps? A to B, B to C and C to D, and the energy profile for this reaction is given below. Here you can visualize the presence of intermediates as well as transition states when the steps, multiple steps are involved, A to B, B to C and C to D. Okay. Then another intermediate is that I left over, benzene. So benzene, it is again a neutral reactive intermediate which is generated when two ortho substituents are removed from the benzene ring, leaving the p orbitals with free electrons. So you may have a triple bond in benzene. In benzene ring you are having a triple bond. It is a highly reactive species because of the existence of the triple bonds, and it is an exceptionally reactive species just like that of your carbocation and another. Then another intermediate is nitrene. This is similar to that of carbene. It is a nitrogen analog of carbene, NH2, NH double dot. So it is an electrophile because it has 5 valence electrons, and it is involved in many chemical reactions and acts as an intermediate, reactive intermediate, and this is formed by two common ways. One is the thermolysis and photolysis of azides with the expulsion of nitrogen gas. Another one is by the expulsion of carbon monoxide from the azide. And next we will move on to another term, reagents in organic chemistry. When you are having a reaction, there exists one substrate, one reagent and another product. So we will see the types of reagents. Okay. The reagents are the chemicals that we add to bring about the specific change to an organic molecule or to the substrate. Any general reaction in organic chemistry can be written like this: substrate plus reagent gives product. Here the substrate is any organic molecule to which we add the reagent, and based on the ability to either donate or abstract a proton, the reagents can be classified as the electrophiles and nucleophiles. Now what is the electrophile? These are electron deficient organic reagents. That is electron loving species. Philic in the sense it is liking. So it can be generalized that all the positive charge containing species are electrophiles. For example, H plus, NO2 plus, nitronium ion, CH3 plus, methyl ion, methyl cation, then Cl plus, chloronium ion. And they may also exist as neutral molecules. Lewis acids like aluminum trichloride, boron trifluoride are examples of neutral electrophiles. Next we will see nucleophiles. Nucleophiles are electron rich organic reagents. So here they are always seeking positively charged carbons. So they seek bonding centers with other nuclei and hence the name nucleophile. So it can be generalized that negative charge containing species are nucleophiles. For example, H minus, H plus we will see, we have seen. Here it is H minus, CH3 minus and Cl minus. And here also we are having neutral nucleophiles. The neutral molecules with a lone pair of electrons on the heteroatom, it can act as a nucleophile. For example, water. On the head of oxygen you are having a lone pair, and in ammonia also on the head of nitrogen you are having a lone pair, and methanol. In methanol on the oxygen atom you are having one lone pair of electron. So all these are the examples for neutral nucleophiles. And thank you everyone for watching this video, and we will meet you again in next videos. Thank you.